Hey everybody, this is the number 4 question for both the AB and BC FRQ from 2008. So let's get started here. I want to highlight some information here. So we know this graph is a graph of V. We know it's differentiable. And then we know it crosses the x-axis at these points, 0, 3, and 5. So let me highlight that. We know exact crossing points, they tell us. We know there are horizontal tangent lines at 1. Bam. And at 4. I don't know how that line just appeared, but that's pretty cool. And then they give us the area of each region. So I will mark that with, how about green? So from 0 to 3, the area of this is 8. From 3 to 5, the area of this is 3. And then 5 to 6, so the region down here would be 2. And we know the starting position right here. So let's start with the first question. So keywords, farthest to the left. It's actually asking a minimum. That was not supposed to happen. It wants the minimum position or the minimum value of x. So let's define x of t equal the position of the particle. So farthest to the left is the same as the minimum. And so we're going to go through the process of that. But the position will be the starting position plus the change in position. Which the starting position is given to us as, well, we know the position at 0. And to find the change in position, if you integrate the velocity, that will give you the change in position. So this is kind of acting weird, but we'll figure it out. So that's going to be our formula for the x position. So we know x sub 0 is given as -2. And then we're going to integrate our velocity function. All right, so the question I ask you all the time, where do minimums and maximums occur? And you should know at critical points or endpoints. We know this function is continuous because it's differentiable. So it has to have a maximum, has to have a minimum, and it'll occur at critical points or endpoints. So let's take the derivative to find the critical points. The derivative of -2 is 0. And then we're taking a derivative integral from a constant to t. It's the derivative with respect to time. So the fundamental theorem says all we do is plug in t. Probably should have done that in black, but you guys get the picture. So to find the critical points, we want to know when this equals 0. So if you set that equal to 0, let me fix that. You can look at the graph. They tell you in the information that it equals 0 at 0, 3, and 5. So how do we know when it's furthest to the left? It has to occur at one of these critical points, or the other option, it happens at the endpoints. So if we can find the position at all of those, whichever one's the smallest has to be the minimum. So we need the position at the left endpoint, the position at our critical points, and the position at our right endpoint, which was given as 6. Well, 0 is easy. They tell us that. That's -2. For the rest, we need to integrate this one from 0 to 3. I don't know why it's making those weird marks. Let me fix that. This thing's tripping out. I think my iPad is on drugs. It's just doing whatever it wants. There we go. And this one will be from 0 to 5. And the last one, we want the change in position from 0. I don't know why those marks are appearing randomly on the screen. I really do think my iPad's on drugs. Do you see that? Just randomly appearing? Really strange. That is really weird. I don't know what's happening. All right, so how do we find the integral from 0 to 3? It's just the net area of our graph, which is clearly -8. So we get -10 for that. And then for the integral from 0 to 5, you're going to get -8 plus 3. So it's going to be -5. And that's -7. And then the integral from 0 to 6, that's going to be +3 minus 10. So it's -7. So the minimum value of x clearly is -10. So that's going to be when it's furthest to the left. So let's read the question again, make sure we answer it correctly. So for both time, find both the time and position of the particle when the particle is furthest to the left. So we need the time and position, so we need to state the particle is furthest to the left Whoa, it's tripping out again. I'm telling you, don't do drugs. Is furthest to the left at t equals, that's 3, and the position is -10. All right, I think we answered both those questions. Now to go to part B. Let me erase the stuff. I don't know what's happening to my screen. It's tripping out. I hope I don't need the stuff I'm erasing right now. That'd be a bummer. I guess I should have read the question first, but oh well. Whoa. Sorry, OCDers. The screen's probably tripping you out. And I can't erase some of these dots. It's weird. These dots that aren't erasing, I don't know what's going on. It is like doing its own thing. Here, let me put a white box all around it. There, it's all gone. And let's start. Question 2. I should erase this stuff. All right. For how many values of t, where t is between 0 and 6 inclusive, is the particle at -8? Now I'm very sad because I erased all my stuff from before, and that would have been very helpful. Let me see if I can remember these Okay, let me get all my positions from before. So remember, x of 0 was -2, and x of 3 was, whoa, -10. These spots are starting to appear again. What's going on? And x of 5, wow, I don't know why this is just weird. So we're going to increase by 3, so it's going to be -7. And x of 6 is going to decrease by 2, that's -9. Okay, so those are basically the maxes, mins, or relative maxes and relative mins of this whole function. So if we want to know how many times x equals -8, we could use the intermediate value theorem. So let's see, we have, let's do this. We have -2 is less than or equal to -8. Let's back up, sorry about that. Those spots won't erase. I don't know what's going on. Those 4 little dots you see, we have to deal with it. So it's -2 is x of 0, which is less than, no, greater than, I don't know my marks, -8, which is greater than x of 3, which is -10. So, intermediate value theorem, since -8 is between x of 0 and x of 3, therefore, there must be a time t, and it's going to be between 0 and 3, because those are the 2 points that -8's between. Such that x of t would equal -8. There's 1. We are going to do that 2 more times. I'm not going to write all that out again just to save time, but if you see -8 is between -10 and -7, we're using the same logic. There's going to be another time between 3 and 5, and again between -7 and -9, using the same logic. Since -8's between that, there must be a time between 5 and 6. So if we put all those 3 together, our conclusion, there must be, this pen is really tripping out. I know I write poorly, but that's even worse than my normal. After we do all the blah, 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 repeat that for 2 more times. Therefore, that is so weird. There must be at least 3 times where, sorry, my brain is spinning here. When particle is at x equals -8. All right, we probably didn't need that at least 3, but we're good with that. All right, on to part C. Let me erase. I'm just going to cover this again. We're getting layer over layer over layer, but hopefully we're good. All right, so part C. On an interval from 2 to 3, they want to know if the speed is increasing or decreasing. You guys should know the justification for speed increasing or decreasing. The speed will increase if the velocity and acceleration have the same sign, and the speed will be decreasing if the velocity and acceleration have the opposite signs. You have to know that. So, velocity is easy from 2 to 3. In this region, it's easy to see that the velocity is negative. So let's go ahead and state that. I don't know why it's doing that. I'm guessing it's because of what I've done before, covering up with a white box, but I don't know. V of t is negative. Whoa, see, that is weird. That is weird. Okay, V of t is negative on the interval. That is so bizarre. On the interval from 2 to 3. Let's just look at the graph. Clearly, since it crosses at 3, it's negative from 2 to 3. But how do we know about the acceleration? Well, first of all, we must know that the acceleration is the derivative of v of t. Well, we have v of t. Now we know that if a function is increasing, then its derivative must be positive. So, on the interval, let me highlight this time. Whoops, that's not highlighting. Let's try highlighting. On that interval right there that I just colored in, clearly v of t is increasing. So we can say, I don't need that therefore. Whoa. So bizarre. Whoa. Okay. This is so weird. It's got to do with me covering with white instead of erasing everything. But I won't do that anymore, and hopefully it'll fix the problem. And actually, man, I don't even need this. Oh, that was weird. See that? That was weird. So a of t, which is v of t, is negative on the interval from 2 to 3 because v of t is increasing on that interval. All right, so we have the velocity is negative and acceleration is negative, and therefore we can conclude the speed of the particle is increasing Whoa. Okay. Man, I think maybe it's me on drugs and not my iPad because I did something very strange. Everything is off. clearly, if v of t is increasing, it should be positive on that region. Whoa. And then that changes my answer. The speed of the particle is not increasing. Whoa, look at that. That's weird. You see it? Whoa. That's weird. Oh, things are, okay. All right. The speed of the particle is decreasing. On 2 to 3 because v of t and a of t have opposite signs. On the interval 2 to 3. Bam. Okay, we have to deal with one more problem. Hopefully, I can get through this without too many more weird things happening. I am again going to try to cover this with a box. I think that's where all my problems are stemming from. When I erase it, the box gets, I don't know, something weird is happening. During what time interval, if any, is the acceleration of the particle negative? Oh, very interesting, because we just kind of did this. We're going to have two intervals. So it's the same logic, kind of weird. I don't know why they have this question, because we needed this on part C. But if the velocity is decreasing, its derivative is negative, and we know its derivative acceleration. So if you look in the graph, we can state that v of t, which is, v prime of t, which is a of t, is negative on, the interval from 0 to 1. Okay, I'm not going to erase that. And 4 to 6. And why? Well, we know that if v is decreasing, v prime will be negative. So our reason, because, whoa, weird stuff. Because v of t is decreasing on those intervals. All right, that was a rough one. A lot of weird stuff happening in my brain, doing weird stuff, but that's it. If you have any questions, just let me know. And I guess I'll start working on the next one. Bye.